Okay, this should be our last video on simplifying rational exponents and radical expressions. So we're doing some operations on these, expressions. Pardon me. So when you have the same radicand, remembering that the radicand is the number that is under the radical sign. Excuse me here while I get something to write with. Okay, so the radicand here is y, and they're the same, and the index is the same, and that's important. That makes them like terms, as long as the index is the same and the radicand is the same, whether it's a variable or a number. Okay, then you can add them just like terms. So 3 cube roots of y plus 4 cube roots of y would equal 7 cube roots of y. That's simple. Notice the index doesn't change, the radicand doesn't change. It's just we had 3 of them and we added 4 more of them, and now we have 7 of them, cube roots of y. Down here, these are square roots. And we can see that what's under the radicands are not the same, but on the other hand, the radicands are also not simplified. So we can start by taking this expression on the left and saying, okay, well, the square root of 9w to the 5th is the square root of 9 times the square root of w to the 5th. And I can simplify that by saying the square root of 9 is 3. And the square root of w to the 5th, I divide 5 by 2, because my index is 2. 5 divided by 2 is 2, so that gives me a w squared on the outside, and it has a remainder of 1. So that remainder of 1, w to the 1st, has to stay under the radical. Okay, so now let's simplify this negative w square roots of w cubed. Again, the index is 2, so nothing I can do with this term on the outside at this point, except now it's times, well, the square root of w cubed. 3 divided by 2, so take this power and divide it by the index. 3 divided by 2 is 1, remainder 1. So w to the 1st, there's my 1, and then the remainder was 1, so w to the 1st has to remain under the radical. So when we divide this power divided by the index, the whole number part of the solution becomes the exponent on the outside. The remainder becomes the exponent on the inside. So what do we have over here on the left? This expression is 3w squared square roots of w. Over here we have minus, well, w times w is w squared times the square root of w. And now we can see we have like terms. The index is the same, the radical is the same. So we subtract 3w squared minus w squared is 2w squared square roots of w. And that's our answer. Alright, so here's some practice. My suggestion is you pause the video, try these on your own, and while you're working then, when you come back, the work and answers will be there. Okay, so in the first problem, we could simplify the square root of 25x cubed, because the square root of 25 is 5, so that gets to come out from the radical. And x cubed contains an x squared, so the square root of that is x. 3 divided by 2, our index is 1, remainder 1. So the 1 came out, and 1 had to remain. That in turn, 6 times 5 times x is 30x, so that's what we see over here on the right. So it's 30x square roots of x. The second expression, there's nothing we can do to simplify that radical, because 5, the square root of 5x, there's no perfect squares contained there. So therefore, this, what you see on the right, is the answer to this addition problem. They are not like terms, so we cannot combine them anymore. The second problem, we have 1/5 square roots of w plus 3/5 square roots of w. We just add the coefficients. 1/5 plus 3/5 is 4/5 square roots of w. Simply done. And the last problem down here, notice that this square that's outside the parentheses only goes with what's in the parentheses. It does not go with the 3. The 3 is outside the parentheses. So when I raise a power to a power, I have to multiply the exponents. When I take 1/2 times 2, I get 1, which we see over here on the right. 3 times 2 is 6, which we also see over here on the right. So this first expression became this expression, minus. In this case, again, I'm going to take the exponents and multiply them times the exponent on the outside, which is 1/3. 3 times 1/3 is 1. We see that over here. And then 18 times 1/3 is 6, which we see over here. So this expression became this expression. Well, 3xy to the 6 minus 1xy to the 6 equals 2xy to the 6. Just notice that that 6 does not look like an exponent, so I'm going to erase that and fix it. That's an exponent. It should be up here. Okay, that was that section. We're not going to worry about application at this point. We'll do some application later. So I'm going to skip this. If you want to look at it, you're welcome to do that. But that's the end of this video and the end of today's lesson. So you should be able to do on the worksheet, and this is worksheet 6.2. Whoops. Worksheet 6.2, Practice B. I know it's going to sound like a lot, but you really need to practice these skills. Pardon me. So I want you to do problem numbers 1 through 30, all of them. But here's the deal. On Canvas, I am posting the work and answers to all the odd-numbered problems. So if you get stuck, go back and look at the work and answers to the odd-numbered ones. So you should then, if you get stuck on an odd one, then the next problem, the next even problem number, you should be able to have a hint about. You know, they're not paired exactly, but pretty much every type of problem is there twice. So look at an odd numbered problem that's like the one you're doing, and you can see the work. Okay, have a great day. I will see you next week.